Hi, this is Tom, amateur radio call sign N8FDY, and today it's time for another meter review. This time we're doing the Greenlee DM-860A. This is a 50,000 count meter, and it's the number 3 in the series of 50,000 count meters. This is packed in the traditional Greenlee way with the blister pack, so let's see what you get. All right. Of course, you get their little brochure. You get silicone leads that are gold-plated. You get a thermocouple. Of course, you have the meter, and you get a nice little carrying case, and of course, a full manual in multiple languages. And, oh yes, your certificate of conformity. And your little comparison sheet of the different models. These are silicone, and they're flexible, they're gold plated, and they have the Cat 4 protectors. So you won't need to get new leads because these should be fine. But we're not testing the leads today, we're testing the meter. So let's turn it on and see what happens. All right, there is a backlight, and it's pretty bright. This has a dual display. This is like this is the 5-digit display here, and then a 4-digit display up here. This meter is actually made by Bryman, and it's rebranded by Greenlee and supported in Greenlee with their limited lifetime warranty in the US. And because it's a Bryman, it remembers where it is. When you select something, let's pick DC volts. And you notice it says DC volts. Now let's switch it to AC and DC volts. Turn it off. Turn it back on. And you see it's still in the same place. Does that with, let's try over here. Right now we're in the diode mode. Let's switch it to capacitor mode. We can change and go back, and it's still in capacitor mode. We can turn it all the way off and turn it back on. Let's turn the backlight back on, go back over here, and we're still in capacitor mode. We can change it to diode mode. We can go off somewhere else. We can come back. We're still in diode mode. We turn it off altogether, and then we turn it back on. Turn the backlight back on, and we go over here, and we're still in diode mode. So it does remember the last thing you selected for each position on the rotary switch. Let's go over some of the features of this meter. This meter has a dual display that shows 2 measurements, such as AC voltage and frequency at the same time. It has the beep jack to tell you have the leads in the wrong spot when you're doing current or switching back to some other mode. It has an AC bandwidth of 100 kilohertz for voltage and 220 kilohertz for current. It has a min-max function. It has a crest capture mode, which shows peak voltages or currents. It's a 50,000 count meter, but you can go to 500,000 count on DC voltage. has relative zero mode. Of course, it's automatic or manual ranging. It has intelligent automatic off, and it has a backlight that is pretty bright and stays on for a while. Now we're going to do some DC voltages. Here is 2.5005, and we get 2.5010. Here is 5.0009, and we get 5.0018. Here is 7.5016, and we get 7.503. Here is 10.0015, and we get 10.004. Now the way we came to these measurements is we use a Keithley DM-860A that was calibrated in February, and I measure this voltage source with that, and that's what I use as the reference voltages. This meter has a problem with the 5-volt range that I discovered, and it was disappointing because I had high hopes for this meter. Admittedly, it's only off by, let's see, it's off by 100 microvolts in one spot, and it's off by 1.1 millivolt in the worst spot. But so it's not much off, but it is disappointing because this had the most stringent specifications for DC volts, so I thought it would be the most accurate meter, but unfortunately it can't meet its own specifications in the 5-volt range. All the other voltage ranges, DC voltage ranges, it did fine, but it definitely screwed up. You'll see on the table. There's a written review of this meter that's linked in the description below. It's on my GitHub site. We have all the meter reviews, have a written review, so you can see all the detail. So you don't really have to take notes on this. You could just download that written review. As you can see, here's a picture of me using the Keithley, measuring the voltages, and also all 5 of the 50,000 count meters showing what they have. And you'll see I have pictures of each one of the values that this guy missed. All the measurements taken in the millivolt range met the specifications as stated in the manual. 5 of the measurements taken in the 5-volt range did not meet the specifications in the manual. They are anywhere from 100 microvolts to 1.1 millivolt off. The specifications in the manual for the 5-volt range and the millivolt range were the most stringent specifications in the group of 5 meters. So it's very disappointing that the 5-volt range couldn't meet those specifications. All right, let's go to AC voltage. Well, here we have 2 volts, AC 60 hertz, and you see the meter reads it as 59.59 hertz at 2 volts. Here's all the AC voltages that I tested, and they all met the specifications stated in the manual. And the specifications for the AC millivolts is the most accurate and highest specification of this group of 5 meters. Now we're going to do AC plus DC. We have 3 volts DC, as close as we can get it on this arbitrary waveform generator. And we have 2 volts AC, again as close as we can get on this arbitrary waveform generator. And now we're going to ask it for what the AC plus DC is. And that is 3.60. Okay, the way we do true RMS AC plus DC is you take the square root of the AC voltage squared plus the DC voltage squared. So I have that here in this calculator, and we ask for the answer because we have 2 volts and 3 volts. And so that is the square root of 13. And that equals 3.6055. So it's pretty close, 3.60. That, of course, is one of the advantages of these 50,000 count meters, is it has true AC plus DC RMS. The AC plus DC specification, these are the voltages I tested. Again, the meter met its specification, and the AC plus DC specification in the manual was again the highest in this group of meters. Now it's time for some current measurements. Again, my homemade current board, I measured with Keithley, the DM-860A, and came up with the currents. I'm using a battery to avoid the noise of a power supply. All right, we have it set to the microamp range, but I plugged it into the amps, and it complains at me. So we'll plug it in. To show you the beep part of the beep jack, it doesn't like it in the amps when I have it set to microamps, so let's put it in the correct one. This is 0.89 microamps, and it reads as 0.89. Oh, now it's 0.90. 89. All right. It's going to drift back and forth, but we're going to count it as 89. Here's 9.21 microamps, and it reads it as 9.21. Oh, 22. It's drifting a little bit between them. But we're going to count it as 9.21. Here is 99.0 microamps. And we get 99.07. 08. Here is 131.8 microamps. And we get 131.97. Now we're going to switch to the milliamp range. Here's 1 milliamp, and it reads 1.005 milliamps. Here's 9.98 milliamps, and it reads it as 9.993. Here's 99.4 milliamps, and it reads it as 99.44. Here's a table of all the current measurements, and all the measurements met the specifications as stated in the manual. Comparing the Greenlee's accuracy specifications to the other meters in this group, the Greenlee has more ranges that are the best accuracy specification in this group. Unfortunately, the 5-volt range didn't meet its specification, but all the other ones did. So I rank this as, for the voltage and current, this is really the #1 meter because it has most accurate specifications for most ranges. Well, I've switched it to resistance, but I didn't change the leads, and you can see it's warning me again that I have to move the leads. All right, we'll do some resistance measurements. First, let's zero out the leads. Oh, we're in continuity mode. That's not good. All right, we're in resistance mode. All right, this says it's about 0.08 ohms. So let's use the delta function to zero that out. And let's start measuring some resistors. This is a 1.004 resistor, and it reads it as 1.01. Here is a 10.007 ohm resistor, and it reads it as 10.08. Here is a 100.069 resistor, and it reads it as 100.06. Here's a 1.0001 kilo ohm resistor, and it reads it as 1.0004. Here is a 10.002 kilo ohm resistor, and it reads it as 10.002. Here's a 100.02 kiloohm resistor, and it reads it as 100.04 kiloohms. Here's a 0.997 megaohm resistor, and it reads it as 0.9947. Here's a 9.97 megaohm resistor, and it reads it as 9.982. Well, as you can see in the table, these are all the resistance measurements I did, and the measurements met the specification as stated in the manual. Now it's time to measure some capacitance values. We have 0.03 nanofarads, which is 30 picofarads of stray capacitance. So we're going to zero that out with the delta function. This is a 12.36 picofarad capacitor, which is really, really low for this meter. And the meter reads it as 0.01 nanofarads, which is essentially 10 picofarads. But this is way too low in the range to really be useful. So we will not count that against this meter because it wasn't designed to do this low a capacitance. Here's 102.56 picofarads, and it reads it as 0.11 nanofarads, which turns out to be about 110 picofarads. Again, this is a really low value capacitor to be using on this meter. I don't think it was designed to do this low. Here's 1.005 nanofarad, and it reads it as 1.02 nanofarad. Here's 9.921 nanofarad, and it reads it as 9.98. Here's 99.51 nanofarads, and it reads it as 99.4. Here's 1.009 microfarads, and it reads it as 1.008 microfarads. Here's 10.294 microfarads, and it reads it as 10.91. 10.92. Here's 112.2 microfarads, and it reads it as 113.1. Here's 944.5 microfarads, and it reads it as 1006 microfarads. Well, as you can see in this table, all the capacitance measurements met the specifications as stated in the manual. The nanofarad specifications is the most stringent of this set of meters. You also notice that the two lowest values we measured, the 10 picofarad and the 100 picofarad, are just too low, and their uncertainty numbers are too high to really make them useful measurements. So we just don't use this meter for that. If you want to measure lower capacitors with accuracy, you're going to need to get an LCR meter. Also note that the high microfarad ranges, the specifications are the worst of the 5 meters in this group. Comparing the Greenlee to the other meters in this group for resistance and capacitance, the Greenlee did meet all its specifications, but only 2 specifications are the highest, which is the low and the high nanofarad range. And the high microfarad range is among the least accurate specifications in the group. Now it's time for some continuity testing. We'll bring out the ProMaster probes, and let's see what happens. We're in continuity mode. It definitely latches. Let's see how fast we can go. Fast enough for me. This meter can measure decibels, which is essentially a AC voltage measurement, but it's referenced to 1 milliwatt. And because it uses voltage and power, you need to have a constant, which would be the impedance. So you can adjust this meter to use an impedance anywhere from 4 ohms to 1200 ohms. And in this case, we're going to use 50 ohms because my arbitrary waveform generator only has 2 output impedances, either 50 ohms or high impedance. So we're going to make sure that I picked a 50 ohm resistor. Here we go. It's 50.04 ohms. I think we're good. So we will use that as our termination. We'll switch over to voltages. And we will hit the select button till we get to dBs. So we have a 50 ohm resistor. We verified it. Now we're going to switch over to AC voltage. And we're going to hit select until we notice how it said dB there. Now we're in the dB range, dBms. Let's go off and back on, and it shows you we're at 50. We're at 50. If you hit range while you're in the dB mode, it will change the impedance. Now we're at 600, which is the traditional audio impedance used for dBm. But again, since this meter doesn't, since this generator doesn't handle 600 ohm output, we will go up and see 1200 is the highest. And if we go again, it'll go take us back to 4 and 8. If you want to measure speakers, 16, 32, there we're at 50. So we will turn on the arbitrary waveform generator. We're feeding 10 dBm into 50 ohm load at 60 hertz. And you see the meter's reading 10.01 at 59.99. Now we're going to take her up to 5 kilohertz. And you see that the meter's now reading 4.99. Oh, now 5 kilohertz, and it's reading 10 dB. Let's take her down to minus 20 dB. We're at minus 20 dBm. Let's switch over to the millivolt scale and see what that looks like. It's a little closer, minus 20. Let's try minus 50. Well, that's not too bad for minus 50. Here's 20 dBm. Let's try higher frequency. Let's go to 10 kilohertz. Here's 10 kilohertz at 20 dBm. Now this meter does logging. It uses a extra cost optional interface. It plugs here. Here is the interface. It's $77 plus some change. Got it from Amazon. It comes with USB 2 and an optical interface that plugs on the back here, like that. So, and this plugs into your computer. The software comes on a CD. This software is from 2016. I was able to load it on a virtual Windows 11 ARM on my Mac Studio M1 running parallels. So it's not as convenient, I would say, as a Bluetooth, which it doesn't have. You know, the EV Blog 121GW had the Bluetooth built in. You didn't need to buy anything extra. Or you could record it right to the SD card, the micro SD card right inside the meter. This, the only thing you can do is connect it to a PC. So if you have a laptop running Windows, it's no problem. You can take it wherever you want. For me, it's not as convenient because, you know, I'm an Apple guy, so I don't really have a Windows laptop. To change the battery, you have to take off the boot, which is a little tougher than some. This is a really tightly fit boot. And then there's a couple of Phillips screws. You pop that out, and there's the 9-volt battery. If you want to change the fuses, you gotta, of course, remove the battery door. And there's 4 screws, 2 here, 2 inside the battery thing. And then you pull it out and change the fuses that way. And then I think that's inconvenient, but a lot of meters do it that way. Well, let's cover the pros and cons of this meter. Well, the good parts of this meter is it's third-party safety tested by UL. It has a dual display with bright backlight. It's the leader in accuracy specifications in more categories than any of the other meters in this group of 50,000 count meters. And it has the Greenlee limited lifetime warranty. Now some of the things that aren't so good. It didn't meet the accuracy specifications in the 5-volt DC range. I'm not sure what's going on there, and it's just my unit, because remember, this is a sample of 1, so you probably won't get this problem, but I noticed it. When I get time in the future, I will contact Greenlee and see what they have to say about it. The other thing is the USB interface to the PC is an extra cost option. Some lower cost meters include that. We haven't reviewed those, but we will be. There's no Bluetooth support. And of course, you have to disassemble the meter to change the fuses. Notwithstanding the problem in the 5-volt range, where it was off a little bit, 100 microvolts to 1.1 millivolt, and that happened on the 1 volt measurement, the 2 volt, 3 volt, 4 volt, and 5 volt. The 2.5 volt was fine. So that is a mystery, but I will contact Greenlee when I get time and see what they have to say, and if they do say anything, I will make a follow-up. But I wouldn't let that dissuade you. I'm not going to lose sleep over 1.1 millivolt of accuracy. It only irks me because they have specified the most stringent accuracy for the low voltage range that beats all the other meters. So I was excited about that until I found out it didn't meet it. But regardless of that, it has more accurate specifications in many of the areas than the other meters, including the Fluke 289. Actually, the 289 has been somewhat of a disappointment. But this is a pretty good meter. It has Greenlee support, and it's not that expensive. I do know that this is really a Bryman meter, and you could get the equivalent Bryman meter cheaper if you want to buy it from EU or other places. But if you want the support and you want to support a local company, if you're in the U.S., then definitely get this. If you're outside of the U.S., if you're the EU or Asia market, you could get the Bryman equivalent. And Bryman, of course, does sell the cable and the software separately. And I'm pretty sure it's the same stuff, but I really don't know because I didn't buy it and test it myself. So, but I would say this is a good meter if you don't need graphing. And if you do need graphing, I mean, you can graph the data from the PC software. I mean, you can export a comma-separated value file, and you use whatever graphing software you want in Excel or whatever. So you could do that. But if you want the meter to graph on its own screen, the only two meters I've seen so far and have are the Unity 181 or the Fluke 289. And we'll get into those reviews later, but I have problems with both of those, so I can't recommend either one. And again, it's one of those, it's probably a sample of one problem, and it's not a systemic thing. It's just my luck of the Irish. I ended up with some meters that had some problems. But what are you going to do? So I hope this helps. And we're going to have plenty more meter reviews. We're going to have a little bit of a pause, unfortunately, but outside of that, we'll get back to doing the other two 50,000 count meters, and then we'll go to the wonderful world of 10 to 20,000 count meters, which is definitely a mixed bag of all kinds of things, and it'll probably take the longest because there's a lot of those, and they don't always do what you think they do. Just to give you a preview of what's coming up. Anyway. So this is Tom, N8FDY, saying 73, and take it easy.